Actually, you need to click on. No, I need to click on. All right, good morning. How are you all feeling? Pumped up for the best slot of the day, 8:30 in the morning? Well, thanks for showing up in such a big number. My name's Georg Hinterhofer with my colleague, Roop. I'm not even trying to pretend that I know how to pronounce his middle name and even his last name, so I'm not even trying that. Today we're going to talk a bit about WAP and ARR, all very cool three-letter acronyms, supposed to replace other three-letter acronyms we have. Very cool. Before we kind of like get into technical stuff, I want to talk a bit about the pirate's choice. All right, ARR. So, if you have been to Greg's Taylor session yesterday on which TLA to choose, that's probably nothing new to you. If you have not been, it's just a quick reminder that where we would want you to go if you feel that pre-auth is still, or reverse proxying is still required in your organization, we would like you to know that the strategic thing to do from a Microsoft perspective is WAP. So the web application proxy is the product that will get the work done, that will have more features coming in upcoming releases. So we will see a massive investor. ARR is kind of like what did Greg say. It was kind of like a point-in-time thing we had, so it's not going to see any massive depth on that. It's not going to get any pre-auth capabilities at all. It's doing the job just fine. All right, just a quick feature comparison so that you know. Pre-authentication is kind of like the big differentiator between both, and like the prerequisites. So ARR, you just slam it on an IIS box and you're good, right? So you just put up an IIS box, you put ARR on it, and you're done. So WAP does a bit more. It needs a bit more. It needs 2012 R2 ADFS. It needs a 2012 R2 box to install it all. It requires a separate load balancer. There's more work to configure it. So just to get you on the track, ARR is kind of like the thing that's just working out there with the caveat of not doing pre-auth, while WAP will get the work done in the future. And we'll talk a bit about what we have now and what we will get, really. All right, and with that, I'm going to turn over to my pirate colleague, Roop. Okay. Please, no more pirate jokes. Thank you for that.
Yeah, I was about to say that. I'm not going to try saying R. Okay, so I'll leave it till there, and that's the last pirate joke. So let's start off. We've got a lot of content to cover, so I might zoom through some of them. So don't feel bad, but I'll try to cover as much as possible. So what is ARR? So it basically stands for Application Request Routing. And it sits, or rather you can think of it as an extension, okay? Like how you have an Outlook add-in. An add-in adds capabilities to Outlook. A plugin would add capabilities to Internet Explorer. So same way, ARR is an extension to IIS. So it sits on top of IIS. So the basic prerequisite is you just need IIS on any box. And then you install ARR. The ARR itself is a free download. And even the usage of ARR is free. So you don't have to license it, or it doesn't say that if you've got more than 10,000 connections coming in, you have to pay some kind of a license. It's a free downloadable extension that you can use within your environment. And it is not specific to Exchange. Okay, it's agnostic to Exchange. It doesn't know. As long as it's a web request, it will do whatever you've told it to do. The ARR extension is very feature-rich. So it's actually used in industries where, where they are of the type of content distribution networks, where there's a lot of data that's being sent across. So some of the features, as you can see on the slide, are listed below. But what we are going to use is only a small subset, only probably a reverse proxy component. And it's got this very interesting behavior or an interesting characteristic, which is the load balancing, an inbuilt load balancing mechanism. So both when you tie them, it gives a very compelling solution. Okay, so because we're all Exchange engineers here, though Exchange is so dependent on IIS, we still don't open the IIS admin console. We just look at it sometimes. But so from the perspective of an Exchange admin, the things that you would need to understand about IIS ARR is what I'm going to talk about. Okay, just a functional overview. And this is important so that you know how it works or what are the underlying, the cogs within the whole system. So the first component that is there within IIS ARR is called the URL rewrite. And in this module is responsible for doing the URL filtering. Okay, so this is where all the magic happens. So this is where all the filtering, whether you want to allow the URL, the requested URL that's coming from the client, whether it has to be allowed, denied, and you can do many fancy things, but I'm just going to stick to Exchange. So from the Exchange perspective, we'll either allow it or deny it. Okay. Once we validate, yes, this URL has to be sent down to my CAS servers, before that, there is another component that sits there. It's called the Web Farm Framework module. It can also be interchangeably called as the Server Farm Framework module. But the catchword over there is farm. So a farm is nothing but a collection of similar servers providing a similar service. So in Exchange, it's nothing but the CAS servers, a group of CAS servers, because they are similar servers providing client access. And it's got very interesting characteristics. I'll leave that for another slide. But so how this all works is on the top, you have various clients. And when I mean various clients, all these clients should be using the HTTP as a transport protocol. Okay, the mechanism, it has to be HTTP. If it is other than HTTP, it wouldn't work. So basically, because it's IIS, IIS is HTTP, so it all has to be HTTP based. So that this also applies to MAPI HTTP, Alchemy, the new protocol that's coming out in SP1, or it's out in SP1. So it is effective even for that. So when the traffic comes and hits the IIS ARR server, the first component that picks it up is the URL rewrite, where the filtering takes place. Once the filtering takes place, then, depending, let's say it's allowed, it goes down to the next component, which is the web farm properties. And then ultimately, depending, it will be sent to the various CAS servers that you have there. OK, so the first component, let's just put it in theory. So the first component is the URL rewrite. And the most important component that we are picking off this component is the URL filtering, as I mentioned earlier. And this is where the reverse proxy component is of the IIS ARR. It also has something interesting, which is the pattern matching or regular expression. Now, let's say you've got lots of URLs. Okay, just keep Exchange aside. Let's say you've got multiple applications. If you had to create a rule for each URL, that will be like cumbersome. So wouldn't it be nice if you had some way of matching all these similar URLs? Like for Exchange itself, we've got mail.contoso.com/OVA/ECP/EWS. So they have a similar pattern. So why not create one rule which can encompass all these rules? So that's what you have a regular expression. And in Exchange, we know transport, we have regular expressions. So that's similar. OK, it's ASP.NET, so the same logic applies. The next one is a web farm, and these are some of the. It's got like seven properties that you can play around with, but the ones that I'm calling out are the ones that are interesting for the Exchange admin. So the first one is load balancing. Within IIS ARR, out of the box, within the web farm framework, you've got 7 different algorithms that you can pick from, and I'll show you what those 7 are. Next is if you ever want proper or effective load balancing to take place, you have to make sure that your health check happens properly. Because you don't want to send traffic to a server, a CAS server, that is down or that's unhealthy. So if you want effective or proper load balancing, health check has to be successful. And health checking is inbuilt again within IIS ARR. The next is affinity. Now, this one is helpful in the Exchange 2007 or Exchange 2010 world, where all your traffic, you had to maintain affinity for all the traffic. Now, it doesn't apply to Exchange 2013 anymore, but I still had to put that so that you know that it still applies, and you have the ability to maintain affinity. And that affinity is restricted to cookie affinity, okay, because it's all HTTP. HTTP can only understand cookie, so that's where it sticks at. And the last is monitoring and management. This is like a nice dashboard because you're effectively pumping so much traffic through the IIS ARR servers. You would like to get an understanding as to whether the IIS ARR servers are dropping requests, what is the latency for each request, whether it's load balancing effectively, et cetera, et cetera. So it's a nice dashboard. Okay, that's all you can do in that. Okay, and I'm just going to highlight that point again. Free. Okay, so remember that it's free. Okay, so. Okay, so I'm just not trying to stir a controversy because I know we've got partners and vendors over here. So I blame Georg for that. So he's the one clapping. So we'll see the configuration steps. So now we've understood how the whole thing works. Let's see the configuration steps. There are basically 2 options. So probably I've already mentioned this in the blogs if you've read the Exchange team blogs. The first option is the most simplest of all. And I'll just walk you through. I'm not going to go into the gory details. It's pretty straightforward anyway, but I'm just going to use this to build my slide. So the first step that you'll perform, there are basically 4 steps. In 4 steps, you're done. So the first step is creating the server farm. So a server farm, as I mentioned, is nothing but a collection of similar servers providing a similar service. So here you just click on Create Server Farm. give it any name you like. Say, in this example, it's Exchange 2013, or I love Exchange, or I love pink unicorns. Anything that you like, but as long as you remember that what this web form is for. Okay? Once you do that, then you add all your CAS servers in. Just put all your FQDNs, all your CAS FQDNs within that AD site for that matter. And ultimately, when you hit finish, it just prompts you, asking you, OK, you've created this form. I think you might need a URL rewrite, where the reverse proxy component is. This is not creating the rule per se. It's just creating a blank rule. Okay, it's just creating a placeholder for you to go and then tweak and play around with it. But just hit yes. You can hit no as well. It's your choice. But I would just say just hit yes. The second step is you've created the form. You just created this collection. Now you need to create or add properties on this collection. And as Georg likes to call it, he calls it the diva. Okay, so because it's very sensitive, it needs all its requirements. So the first thing is caching. Okay, and as I said, these are the characteristics that you can play around with. Again, it's simple. It's not this whole big list of things that you have to remember and know as to what each does what. That's all. Okay, that's all you can have within this component, within the service farm component. The first is caching. Generally, this is turned on by default. We would say just disable it, because why do you want to cache something on a exchange related on an IaaS ARR server which is sitting in the DMZ? Again, security concerns. So just disable the cache. The next is the load balancing, the interesting part that I wanted to show you. So these are the 7 different algorithms that you can pick out from. And the one that is generally turned on is the least current requests. But as I said, you can choose any that you like. Okay, it's not like a Microsoft recommended you have to use whatever, the one that's there. Choose whatever suits your business needs. Okay, but make an informed judgment. Don't just choose something which will probably not be ideal for you. Once you do load balancing, so as I said, if you want effective load balancing, you have to make sure that your health checks are effective or proper, or you're doing true health checks. The way we do it is in IaaS ARR, you have this inbuilt health check feature. Once you click on that, it asks you for the health check URL. And most of you might know, in the Exchange 2013 world, because of managed availability and on the CAS servers, there is the managed availability creates this health check URL. Okay, I use the word create because if you go and search for that healthcheck.html file in the inetserv folder, you wouldn't see it. It creates it, or managed availability creates it and keeps it in memory. Okay, so you literally won't find that file. But if you open a web browser and try to hit that URL, you will get back a 200 OK. And we are using that 200 OK to tell IaaS ARR whether that particular server is up or down. So at the very bottom, you can see acceptable status codes. So I've put number 200. So that is what I'm looking for. Anything other than 200, I know I'm going to say that CAS server is unhealthy, or don't talk to that, or don't send traffic to that. So that's what we are doing there. One thing that has been highlighted over there is the interval. So 5 seconds. So it's again your choice. Choose whether you want to increase the interval. If you think 5 seconds is too aggressive, increase it 30 seconds, 60 seconds, or whatever number you want. Okay. And a quick and easy way within IaaS ARR to check whether the state of the CAS servers is healthy or unhealthy, or whether it's passing or failing the test, is at the very bottom you have that verify URL test button. So when you click on that, it actually initiates the check. And then over here, you can see the first one passes. The second one fails because it was trying to match the status code. So you, as an admin, said, I'm looking for status code 200, but the response comes back with 0. So it says, sorry, it doesn't match. I'm going to drop it. Or I'm not going to use this CAS server, to be more precise. So this is the inbuilt health checking mechanism that is there within IaaS ARR. So this is still, we have just created the farm. You just created this collection. You just tweak these properties on the farm. Now, the most important component is yet to be configured. And that is the URL rewrite, the actual reverse proxy component that's sitting there. And again, that's there within the IaaS console. You just open the IaaS console on the IaaS ARR box. And this is the blank rule that I was talking about. And once you click on that blank rule, I've just put small snippets because it's a slightly big in size. So I'm just going to pick up the ones that are important. The first thing it will ask you is, what pattern do you want to match it against? So to explain this, these are some of the exchange URLs that you will have. Okay, so /OVA, /ECP, /OAB, and /EWS. That's for web services. Now, if I would to tell you, okay, can you give me a URL that would probably match all of them? The closest answer would be something like that, okay? Because that will kind of encompass all the other URLs. And you can also break down the URL into 3 parts. The first column is the HTTPS part. The second part is the host name or the namespace, whatever you want to call it. And the last part is the actual virtual directory, which is going to service your request. So the question that ISARR is asking in the first part is what pattern do you want to match it to, or what's the path you want to match to? And over here we have put an asterisk, meaning just match to anything. Now, obviously this is not the best match because it's a wildcard. It could be any virtual directory for that matter. So what you do is then you go ahead. Okay, when you scroll down, it asks for additional conditions. Okay, are there any other conditions you want to match against? So the first condition I'm going to match against is whether it's HTTPS or not. Okay, we want secure communication, so yes. The second condition that I'm going to match against is the host name or the namespace that you've published, your single namespace that you've published. Once all these conditions are met, and only once all these conditions are met, I'm going to forward it to a farm, or the action that I'm going to perform is forwarded to the farm. And that's the farm that I created earlier, the Exchange 2013 farm. And that's it. Okay, so you're ready. You're up and ready to go. That's your filter. You've done it. If the URL matches that, I'm going to let it through. And that is going to send it to the farm. This farm is going to do the load balancing. And you're done, literally. However, you just have to repeat this process for auto-discover. Because though we say it's a single namespace, you still have auto-discover. So you repeat the same process for auto-discover. So you can see there are two URLs. And you're done, literally. So that's it. In 4 steps, you were able to set up a reverse proxy, which also gave you free load balancing. Okay. Now, just to understand this whole thing, instead of showing a demo, I just brought an animation, and just to show you how this whole thing works. So right on the top, you've got your client, let's say Outlook, using Outlook Anywhere. In the middle, I've just blown out all the guts of the ISARR. So on the top, you've got the URL rewrite, and at the bottom, you've got the farms. And probably you might not be able to read it clearly, so I've set the properties of the farm so you can see the health check that I'm using, and you can also see the load balancing mechanism and affinity is set to no. So let us say the user actually launches Outlook for the first time, so there's an auto-discover URL that will be sent. It'll go and hit the ISARR server. The first thing we'll try to do is we'll try to find a match. So basically that's what we're trying to do. Will it match the first one? No, for obvious reasons. You can just look at it and see it doesn't match. Then we go down the list, just like any type of URL checks. We try and check the second rule. The second rule says, yeah, it's a match. So now what we do is we then forward it to the auto-discover web farm. And the auto-discover web farm in the background is continuously using that health check URL that you've given it, and it knows the state of the CAS servers. It's continuously using that health check URL that you have defined, and it knows whether CAS 1, CAS 2, or CAS 3 is up or down. And in this case, I've just marked CAS 3 as down, red in color. So once the traffic comes in, it automatically distributes it to either CAS 1 or CAS 2. Just to go further, let's say auto-discover completes. Then the next thing that will happen is Outlook Anywhere. So that's probably the URL that is actually sent. Once that is sent, again, we try to do a match. You probably guessed it. It's going to match the first rule. Once it matches the first rule, it's going to send it to the appropriate web farm. Okay? And then from there, depending on the health check status, it's a dynamic table depending on the interval. So in our case, let's say it's 5 seconds. So every 5 seconds, it's actually pinging or polling the CAS servers and knows whether it's up or down. And the last one is just for completeness, Exchange Web Services. So same thing. So I'll not talk. I'll keep quiet for a second. Watch the screen. Okay, there you go. Okay, so now you might be thinking, okay, if you look on the top of the slide, it says option 1. And at the beginning, I said there are 2 options of configuring this whole thing. So you might be thinking, okay, Roop, option 1 seems to do the job. Why do you have option 2 for that, to do something else? The way I say it is, option 1 has some quirks or some kind of drawbacks. And those drawbacks are not because of the product. It is because of how you've configured it. And to understand it, again, another animation. So here you have the CAS server, and the CAS server has all these various virtual directories. And in the middle, you have this ISARR server, and it is configured as per option 1. So as per option 1, that is your health check URL. But if you look very closely at the health check URL, it is /over/healthcheck.htm. So what you're effectively doing is you're actually checking the status of the OVA virtual directory. Now, example. There's an issue with the OAB virtual directory for whatever reasons. Okay, many reasons might be there, but let's say it's down. and the user now requests to download the OAB. So that's probably the URL. It's longer, but I've just truncated it. So that's the request it sends to IS ARR. Now, when it hits the IS ARR server, from the eyes of the IS ARR server, or from the perspective of the IS ARR server, if you look at that, as per the health check, the server is available. So what it does is it sends the traffic across. But what that affects is the end user. The end user will not have the latest offline address book. Similarly, if you just expand that to the Exchange Web Services, similarly, because this is something that has been caused by you, by the admin, because of the way you have kind of set it up. So that's similar. Okay. Now, if I just add 2 more Exchange servers or Exchange CAS servers, and this time, let us say the OAB virtual directory, sorry, the OWA virtual directory is actually down. So again, the IS ARR server is going to perform the health check, but this time, as based on that health check, it says, okay, fine, I'm not getting a response. It's going to mark the whole server down, okay, the whole CAS1 as down. So now, if an OAB request comes in, from the eyes of the IS ARR server, CAS1 is down, the whole CAS server, not the virtual directory, it's the whole CAS. So all requests will go down to the CAS2. As you can see on the top, CAS1's OAB virtual directory is still healthy. But no, because of the way you've configured it, it goes down. So I'm just going to then say, you can guess it, what's going to happen with EWS as well. So think of this in a production environment. Let's say you've got 4,000 users, 2,000 users connecting to CAS1, 2,000 users connecting to CAS2. In this scenario, you would have 4,000 users connecting to CAS2. So that's like a waste of resources for CAS1. Just one virtual directory is down, everybody's sent down to CAS2. Not a great idea. So what's the solution? The easiest answer is you need to perform per protocol health check. Okay, so once you perform per protocol health check, you would know the true state of each virtual directory. And once you know the true state of each virtual directory, IS ARR would know, okay, that virtual directory is down, so I'll send it to another virtual directory, which is another CAS server. So that becomes like true load balancing or effective distribution of the load. And this is what leads us to option 2. Okay, so that's the reason why option 2 is in place. And I'll show you how it works conceptually. So I'm not going to show a demo, but I'm just going to show you how it works actually. So the first and foremost thing, which probably as soon as I do a click now, you would going to release a big sigh, is you will have to register multiple namespace or multiple unique namespaces that corner that you can see there under the CAS server. So you have to have each namespace published on its own unique namespace. So OW will probably be mail.contoso.com, ECP is ecp.contoso.com. Once you do that, then on the IS ARR server, the box in the middle, you have these multiple web farms, and each web farm will have its own unique health check URL. So as you can just scroll your eyes down, you can see each URL is unique, so thereby you're performing unique health checks. So you know the true state of each virtual directory. Okay. Now, yes, from the admin's perspective, I agree, that's a lot of work, that's a lot of management tasks that you have to perform. The admin has to, it's a certificate, multiple SAN names, multiple DNS entries, cost, everything comes into the picture. But from the end user's perspective, the end user doesn't have to remember all these namespaces. The client, let's say Outlook, will get it using auto-discover. The end user, all he will do is when he launches Outlook that's the auto-discover URL that will be performed, and all the rest of the namespaces will automatically come back. So from the end user's perspective, the end user doesn't have to memorize, if I have to download OAB, do I have to go to oab.contoso.com? No. It's all taken care of anyway. The only thing that he's probably going to remember, that he's always been remembering from the past, is mail.contoso.com. That's the mail URL. So yes, option 1 has some limitations, but option 2 has its own limitations. So let's just put this side by side, just a matrix so that it's all clear. So option 1, the first and the foremost one that clearly sticks out is it does not perform per protocol health check. And thereby it's effectively only performing a server availability, okay, not a service availability. It's only checking the state of the server, okay, because of the way you've configured it. And from the admin's perspective, the last 2 columns that you see there, you've got minimal namespace, okay, and that makes it management easy for the admin. However, for option 2, the first 2 columns that you see there is great. You're getting per protocol health check, thereby you're properly doing effective load balancing. But from the admin's perspective, that is the third and the fourth column, lot of overhead management. So if I bring up the good options or good features of option 1 and option 2, it is the ones that are in pink. Okay? So you might be thinking now, okay, Roop, it's great, but can you give me something in the middle? Something that has a goodness of option 1 and goodness of option 2. And I would say, yes, there is an option 3. Okay? So option 3 is pretty new. And you probably are the audience who are going to see it first. The blog is ready in draft. It's going to be published soon. It's gone through its final review. It just has to be published. So option 3 is something that you can utilize. So let us see what does option 3 have. So these are the goodness of option 1 and option 2. I know option 3 is in the middle, but that's a logical placement. Option 3 has to be at the bottom, but that's a logical placement. So so as you can see, I'm just going to animate it so you make sense. Okay, so option 3 has the goodness of both the worlds. So you get, from the admin's perspective, you have less management. From the end user's perspective, you're performing per protocol health check, you're getting load balancing, you're getting everything. Okay, so that's option 3. Let me just show you again, no demo, is how it works. So the first thing is, on the cache side, as I promised, you have only 2 namespaces, one namespace, but the other one for auto-discover. And within the web farms, all the different web farms that you have, these are your health check URLs that you will put in for each web farm. So they are similar, but if you look for the path, it's /over/ECP/ActiveSync, blah, blah, blah. And the way we filter it, now you've simplified something, but in nature, when you simplify something, it affects something else. So now if you think of the IaaS ARR, just for a second, think of IaaS ARR. You've simplified the namespace. Once you simplify the namespace, you need to give IaaS ARR the ability to distinguish the traffic. Because if everything is coming on mail.contoso.com, how does IaaS ARR know that this is OVA traffic, this is ActiveSync traffic, this is OAB traffic? How do you tell IaaS ARR to distinguish that? The way you do that is by the power of the URL rewrite rules. So I'll just show you how it works, and the simplest example I'll take is the OVA URL. So let us say the client fires up mail.contoso.com/OVA. So within the URL rewrite, the first thing you will try and match is the path. So anything after the first single slash is called the path. So we're going to match that. So does it match? Yes, it does. I don't need to tell you that. So then once we match that, we go and try and match the host name part. The name that is there, mail.contoso.com. We also match for HTTPS, but the slide is already busy enough, so I didn't put that. Once we check that, then we send it to the appropriate farm, and that farm is performing the actual health checks. So you're achieving per protocol health checks anyway. And just to expand that, and again, just to clarify all the examples, let's say this time the end user wants to set his out of office. What does that initiate? It initiates a web services query. That web services will go and hit the IaaS ARR box. We start from top down always, just like even in TMG, you start from the top rule. So we try to match OWA, obvious, doesn't match. We try /ECP, doesn't match. We try EWS, yeah, we match. Okay? So once it matches, then we go and try and match the host name. Again, you can see it matches, and then we send it to EWS. So that is it. So that is in simple how option 3 works. And if you have got customers, or if you're intending to have customers who are going to implement, let us say, IaaS ARR, make sure you tell them about option 3. Okay, as I said, we'll be publishing the blog soon, so you should have the steps of how to do it. And if you're already running option 1, it's a few steps, and then you should be done with option 3. Okay, so now with these things in mind, you can see how important IaaS ARR becomes, when you're implementing it. So it's a reverse proxy and doing load balancing. So the question comes up, always is, can you make it highly available? Yes, you can. You can have 2, 3, 4 IaaS ARR servers, use Windows Network Load Balancer or a third-party load balancer. But a third-party load balancer would become an overkill. You can argue, but it can be an overkill because already that load balancer is doing load balancing. IaaS ARR can do load balancing again. So it's a choice, okay? I'm not saying that don't use it. It's a choice. But the simplest answer would be just use Windows Network Load Balancing. And let's say if you have 4 IaaS ARR servers, now you might say, okay, I have to, if I make a change on one IaaS ARR server, I have to then jump to ARR server number 2, ARR server number 3, and server number 4. You don't have to do that. In IaaS, there's a feature called as the IaaS shared config. So let's say you've got 4 ARR servers. So all 4 ARR servers will share one configuration. So if you make a new rule or if you create a new farm, it's going to write to the shared config. And after that, the other 4 is going to pick it up. So from an admin's perspective, it's less of an overhead. So with both of these in place, you can actually get high availability for ARR. And if you come to, in a mixed mode, all this while I was talking about Exchange 2013, but when ARR works for 2007, it works for 2010, it works for 2013, it works absolutely fine. As I told you at the very start, it is not Exchange centric. It doesn't know about Exchange. It's just looking at the URL. The only thing that you have to keep in mind is the legacy namespace. If you have 2000 in the mix, so make sure you just publish the legacy namespace. And the health check, there is no health check in 2007 or 2010, the health check URL. So you will have to use something generic. So when you use something generic, the status codes change because you will not get a 200 OK. So it's 200 to 399. That means it's responding. It doesn't say that it's healthy. It's just saying, OK, I'm responding to your request, to that URL request. OK, so that's the only thing you have to keep in mind. OK, so how are we doing time?
Oh, good.
OK. So now with all this, you've understood how it works. You've understood the 2 components. You've seen the 3 options. And you've seen option number 3 is great. Now I'll just talk about some implementation scenarios, okay, at a very high level. You might be thinking, okay, what's so great? You just put IaaS ARR in a DMZ and then it's a reverse proxy. So these implementation scenarios are unique in the sense that they've come about from discussions that I've had with customers. So that's why it's just unique. And this is not something I'm telling you as a guidance that you have to follow. It is just a food for thought. Okay, so when you're sitting down sometime, if you have a lot of free time, think about this. Okay. So there are 2 rules before we talk about the scenarios. Okay, the first rule is URL rewrite and the web farm are mutually dependent on each other. So they have to be running, on a box. You cannot have URL rewrite and don't install the other component. So they are mutually dependent. However, you can control the behavior of IaaS ARR based on what you configure. I know the statement it'll go over your head, but I'll explain what it means. And the word behavior and configure is what I would like you to keep in mind. So what it means is, if on an IaaS ARR server, if I configure, again I repeat the word, if I configure both the URL rewrite and the web farm, then I get a server that will provide me both reverse proxy and a load balancer. So it's a software load balancer, but still load balancing. If I only configure the URL rewrite component, then I get a reverse proxy. And if I only configure the web farm, I get a software load balancer. So these are the things that you can control or you can make IaaS ARR behave as. So just to, again, show you visually, I like to see things, then that's how I remember. So I thought, OK, I'll bring this up. OK, so on this IaaS ARR server, we've got both the components. As I said, they're mutually dependent. But I do not configure the web farm. OK, that's the reason why I've just faded it out. It's there, but I've not configured it. Now, when the traffic comes and hits the IaaS ARR server, the first component that picks it up is the URL rewrite. And because I've not configured anything, it just is like a pass-through. OK, it just goes down. On the flip side, for load balancers, so again, I've just, you get the point, what I'm trying to make over here. So the traffic comes in, nothing happens. It goes through. It's just a simple load balancer. Okay. So keeping these things in mind, let's take scenario 1. So scenario 1 states, OK, that's where you'll generally keep it, and that's how it's doing everything. But all this time, we were talking about external users. What about internal users? What about this guy? Don't you have to load balance his traffic? Yes, you have to. You might say, OK, I can use DNS round robin. Yes, you can. It'll work effectively. It'll work absolutely fine. But DNS round robin is a load distribution mechanism. It's not a load balancing mechanism. There's a difference between the 2. Both will work, but there are scenarios where one would be more preferable. So then you might ask me, OK, can I do something like this? OK, don't be too smart, but don't do that. OK, you can achieve this, but it's a little bit of a configuration nightmare. But the most important point over there is most businesses wouldn't like that. You're sending all your internal traffic to the DMZ and then back out. So you're hairpinning the traffic. Not a good idea. OK, I would say. So now you might say, OK, then what do I do? Keep those 2 rules in mind, and this is something that you can do. So you decouple it. So one IaaS ARR server, you keep it in the DMZ, make it act like a reverse proxy. Another one, you keep it inside, it acts like a load balancer. So for your internal users, all the traffic goes down to the load balancer, and you're happy. Okay? So now a question might come up. If you're this very, an architect or a consultant who is very, particular about everything. If you look at the lines, everything goes and culminates at this load balancer. So you might tell me, no, Roop, that's a single point of failure. From the connections perspective, okay? From everything, if that goes down, my internal users will be affected, my external users. So I would say, okay, great. If you've got, do that. So all your external traffic hits the reverse proxy. It goes and hits the external load balancer. I'm just calling it external load balance in the sense it's picking up all the external traffic, and then it load balances. For your internal, that's how you go. So even if the external load balancer, it's getting overwhelmed with requests, your internal, end user experience isn't affected. Okay, so these are scenarios, as I said, it's just food for thought. Okay, it's not we are saying follow this guidance or anything. It's just for you to, digest it, if you can. The last scenario for me is the hybrid. We cannot forget our Office 365 hybrid customers. The only difference in hybrid is when you talk about single sign-on. So the one in the middle, you have an ADFS proxy server. And the ADFS proxy server has an ADFS that it's talking to. You can use IS ARR as a reverse proxy and load balancer, both for your on-premises mailboxes, and you can also use it to load balance ADFS proxy, single sign-on, to achieve single sign-on. So this can completely, give you a good solution. So it's an option. I'm not saying you have to use that. And that is it I had. If you have any questions, leave it till the end, please, because Georg has a good number of slides, more than I have. So I'll now hand it over to Georg. Take it away.
All right, thank you, Roop. Can the audience just hear me fine? Mic's still good? So thank you, Roop, for all the Drunken Pirates talk. Appreciate that. So we're going to focus a bit on the web application proxy now. So the web application proxy, as most of you will probably have heard of, is a server role that's contained in Windows 2012 R2. So basically, it's nothing more. You go to Server Manager, you add a feature, it's called remote access, and a subcomponent of that would be the web application proxy server. Can be deployed domain joined or not domain joined, kind of dependent on what you're trying to achieve. We'll talk a bit about that. A common misconception is that we need a 2012 R2DC or GC or schema level or whatever for that. No, we don't. We don't need any 2012 R2 schema extensions, no forest level, no domain level, no such a thing. Basically, what the web role is, it's a web proxy, right? It's a reverse proxy. That's it. Okay? It's an intelligent, somehow, semi-intelligent reverse proxy. For applications, for stuff like for OWA, for ECP, for all the other client protocols, and out of the box, it's also a proxy for ADFS. So previously, when you did like an ADF proxy, you built like a plain Windows box, you went to download site, you pulled the ADFS proxy, installed it. That's what people did. Nope, it's the web server role now. So that's going to be super helpful to get like hybrid deployments going there as well. Provides single sign-on for a bunch of scenarios. We'll talk more about that. It's designed to be deployed in the DMZ. Well, generally, that's a true statement. You can deploy it wherever you want, obviously. You can deploy it in like your internal network if you feel like it. You can deploy it in your DMZ. So that's nothing wrong with that. All right. The logon page that you see, so what I got to see at people at large organizations is that they like to like have customized logon pages, right? Who in here has customized their OWA logon pages? Well, a good number of people. So yep, that's still there. It's still customizable. It's no longer based on IIS, so there's not going to be any HTML file that you can tweak around. It's now all based on configuration in mighty PowerShell. So you do like set ADFS login page, whatever. You can change images there. You can do like disclaimer rules there, whatever you want. So yes, it's still there. You can still customize it. All right, so that's kind of like the topology that we proposed. Again, what we said is you can deploy that wherever you want. There's no strict requirement for web to be DMZ. Obviously, it was designed for that, though. There's one thing popping up already. I'm not sure if you can get this. Like up there, it says ADFS and config store. So yes, web has a hard dependency on ADFS. Even if you don't care about claims off, even if you don't care about KCD, careless constraint delegation being done, you still need to have an ADFS 2012 R2 box around for web to actually do something. The reason for that is that web is storing its config in ADFS, which has its ups and downs. Its downsides obviously being that you need to bring up ADFS boxes, like 1 or 2 if you want HA at least. Its upsides is that with any new web application proxy box you build, you will get the same config there. So just subscribe it to the same ADFS server, and it's going to be done, right? So you bring up more WAP boxes, configuration is being pulled out of ADFS, and you should be good with that. All right. So we obviously need a domain controller for ADFS to be working well. Thank you for that. And we have our backend servers right there, which in our case would be Exchange 2013, 10.7, 2003. Probably no one tested that, though. And it says a load balancer in there. So kind of like, this is where we kind of go apart a bit. R, like our lovely pirate thing, has load balancing built in. 7 forms of load balancing. Come on, how cool is that for free? We don't have that. We just don't. Okay? So WAP doesn't have built-in load balancing. Not for itself, not for other applications. We'll talk a bit about when we come to that. All right. So we do offer reverse proxying for all Exchange-relevant protocols. Let's leave POP3 and IMAP out of the picture here because it's not HTTP-based. So OWA, ECP, ActiveSync, Outlook Anywhere, MAP HTTP, yep, all good. We can do that. The caveat for the time being, though, and it's kind of helpful to keep that in mind, that we can only do pre-authentication for OWA ECP. Okay? So there's no pre-auth going on for all the others, like ActiveSync. I know you want that. I get it. Outlook Anywhere, yeah, we should have that really soon. And the good news is we will get that. So the next WAP release will feature pre-authentication for those as well. Cue for applause, something like that. Come on. So we will get pre-authentication for those as well in there, which is kind of nice. And makes this like the obvious choice if your customer is still longing for pre-auth for all the Exchange protocols. So for the time being, only OWA ECP. And the reason for this is very easy. All the others don't understand the redirection that we give. So when you sign on like to mail.pinkelephants.com, it's going to redirect you to your ADFS sign-in portal. Okay? Now, what would happen if we have Outlook Anywhere going to the ADFS sign-in portal? It's going to say, what? What's that? What's a sign-in portal? And just sit there and do nothing. Okay? So, yep, we'll dream something up for that. But for the time being, just keep in mind, it's done by redirection. And the only thing that's kind of honoring redirection are browsers. So that's kind of where our limitation is coming from. All right. So I want to talk a bit about more of a technical thing. So seeing that this should be like a 300, 350 level session, I slammed in a bunch of slides on how the authentication flow really works, because most of the people just don't really know that and have never seen that before. And this is actually talking about KCD pre-auth flow, and there's a bit more to that. So what's happening is that when the user enters his credentials, we'll take those and get a ticket for him at the KDC and present it to the OWA box. All right, so this was before we had 2013 SP1. So with 2013 SP1, there's actually more possible. So you probably have all heard it before. 2013 SP1 brought claims off finally to OWA and ECP. So it was kind of mentioned in, I think, Brian's session, and Greg mentioned it as well. But all the others, like 2013, like up to CU3, 10.7, could still work fine with KCD pre-auth in place. And honestly, the auth flow is not that different. So I kind of picked those and just left it in there just to walk you through the authentication steps there. All right. So we have a 8A triangle. Thank you for that. We have CAS servers in the backend with authentication set to integrated Windows authentication. So Kerberos, NTLM, whatever you see fit. That's about it. So if any user would log on now to that box, he would see like a credential prompt coming up, no form anymore, just a credential pop-up saying, please enter your credentials here, done with it. All right, so let's add some stuff to that. So we now have a ADFS box, which has a URL that's called sts.fabricam.com. And we also have a web application proxy that we already know can act as an ADFS proxy. So that's kind of where we want our client to go for sts.fabricam.com. And I also gave it like the external URL of mailfabricam.com, WAC over. And, well, obviously, we'll have clients accessing that. So we have like the Thai-looking client up there. That's going to type into his browser, mail.fabricam.com, WAC over. All right. So at that stage, we're going to have a look. Hey, man, do I know you? Do you have any credentials? And we're especially looking for either an auth token or an edge access cookie. Well, at that stage, if that guy has like a fresh browser session open, we won't have either of those. So we'll say, yep, we don't know you, but you can authenticate with us. We're cool with that. And we're going to send him a 307 redirect. But this is the first time I saw a 307 redirect. So redirects are usually like what, 302s, right? So there's not too much documentation around that. So it's basically functionally it's the same. They're just keeping more data while sending clients back. So from a troubleshooting perspective, it's really a 302 if you ever need to. All right. So we are sending the client off to sts.sir8. It's my lab where I played with this at home. So excuse me for the crappy naming of that. So we're sending him off to the STS portal, which is, in turn, the WAP proxy role, right? Our WAP reverse proxy. So we're hitting the ADFS proxy. Well, what's the ADFS proxy going to show us? Ta-da! You all have seen that one before, right? So that's the ADFS logon screen. Again, highly customizable, however you want it. All right, so people are going to enter their credentials there. So, yep, have a look at my super complex password. So we're going to send it off. And there are a bunch of very useful information in there. See, if you have a look at like the URL, I hope you can see it from the back of the room. It says URN app proxy, which kind of means, dear ADFS, I want a authentication token for the WAP proxy itself. Okay? So this is what it's asking for. Okay? It wants to authenticate against the WAP proxy. Not against the application by now. It wants to authenticate against the WAP proxy. We're not there yet. So we are going to get that, slam the credentials back. And there's one more. There's the app realm in there. And the app realm is kind of a correlator to something we call a relying party trust in ADFS. So relying party trust is basically credentials flowing out of ADFS to OWA. We'll see it in the demo on how that looks like. Good. So we get the credentials back there. ADFS says, wow, cool, I love you, man. And it's going to give me back an MSIS off cookie. Okay? So the MSIS off cookie is not good for the web proxy. The MSIS off cookie is good for the ADFS server. Okay? Big difference there. And if you have a look at that, we are going to call, if you have a look at the URL up here again, it's kind of like, yeah, we're asking for an app proxy cookie, blah, blah, blah. OK, so we're not getting back an MSIS off cookie. Very nice. Very cool. The thing is, what's going to happen now is we're going to do the same exact query once again. So the URL in the get command will be exactly the same because we still want a web application token. Right? We don't have that. We have now a token that's good for ADFS. So with the same information plus the MSIS off token, cookie, that we already have, we go back and say, yep, ADFS, you now know me. Please issue a web proxy, a web token for me. Well, and ADFS is just happily going to do that if my credentials line up. And it's going to give me back something we call an auth token. So the auth token basically is a base 64 encoded blob of information. So if you would slam that in, that text block right there, in a base 64 decoder, it would show you all the claims contained. It will show you your URNs. It will show you an issuance state, all of that stuff. It's all going to be there. So if you ever need to troubleshoot it and see what claims are actually flowing out of ADFS, this is the time to do it. This is the only time. This is kind of like in an unencrypted form. So keep in mind that this is still all transferred over SSL. So there's no like data impact there. But after the next call, this auth token will be transferred to something else, and we'll see that. All right. So with the auth token in place, little Greg Taylor, we log on to OWA. So the auth token is good to log on to OWA. Either auth token or edge access cookie, right? So we need any of those. Now we have an auth token. Very nice. So we'll go with the auth token to the web proxy server again on mail.blah, blah, blah, which is now going to be our URL for OWA or ECP, whatever you feel like. And we're going to show our auth token there. Well, obviously, we got an auth token. We need to use it somehow. And we're going to show that auth token there. And with that auth token, we're going to do, guess what? KCDing to the way back. So we're going to go to the KDC, ask for a ticket for mail.blah, and get the ticket and show it back there. So, yep, we have it. And what we get back now is, and we actually logged on by now. So what we're getting back now is an edge access cookie. But that's not necessarily required to log on. So you had an auth token before, and the auth token is far good enough. That's good enough. But the edge access cookie is what we get on like the first logon attempt with the auth token. And the edge access cookie is nothing more than like an encrypted form of the auth token that you will not have access to the private key of that. So that's why I said if you ever need to decrypt that, the auth token is the place to do that. If it gets like to the edge access cookie, there's no way to do that anymore because it's not base64 encoded. There's a private key stored in WAP that's actually used to decrypt that. It's shared across all the WAP boxes, so all the WAP boxes can actually decrypt that. And, but we will not have access to that private key. All right. So we have an edge access cookie. We're happy. And from that moment on, we will just use the edge access cookie to collect to OWA. So with that edge access cookie in place, as long as we don't close the browser window, we will have access to OWA ECP for whatever duration we want, which is quite nice. All right. Very cool. Shows ticket for SPN. Yeah, we'll talk about the SPN a bit later on. There's obviously something else, just pass-through authentication. Well, pass-through, obviously, is far more easier than that. There's not going to be any redirection going on. Same setup, mailfabricam.com. Go to mailfabricam.com. Get back a 401 unauthorized. Please show me your credentials. Enter your credentials. Negotiate. Done. Well, that was quick, wasn't it? So those are the two options we have, basically. So starting with 2013 SP1, we can either do ADFS claims off to the back, we can do KCD off to the back, or we can always do pass-through off to the back. We can always do that. We can do that for any exchange protocol, any given time, right now, right there. All right. So finally, who has ever played around trying to get claims authentication working in Exchange before? Yeah? Managed to get it working? Yeah. Maybe. OK. Bunch of you? Somehow? OK. So good thing is, we had kind of a lame story with ADFS, though, didn't we? We had 2010 out, and there was it was actually a white paper out saying, this is how to configure ADFS, right? And around the SP1-ish time frame, I guess, that white paper just magically disappeared. Just gone. Swallowed by the face of the earth. Thank you for that. So yes, we're back. 2013 SP1 finally gets a ADFS off going for OWA ECP in the current release. If you went to the security session from a bunch of folks yesterday, Greg was in there, I don't know who else was in there, they actually said that we will have ADFS off for more than OWA ECP in the future, like for Outlook Anywhere, which people have been asking for quite a while, really. So that's going to come. It's not there yet, but that's going to come. All right. So we have a SAML 2.0 implementation right there. We're just going to accept the standard claim. Nothing fancy, nothing wrong with that. The kind of bunch of caveats, though. It's an either-or thing, right? So you either go with ADFS off or all the other stuff we have, OK? So there's no way to have like ADFS plus NTLM or ADFS plus form or something like that. It's not going to happen. So you choose ADFS, you turn off all the rest, right? So no FBA, NTLM, secret knock signs, magic beans, whatever you feel like. It's not going to work, OK? There's no support for anything pre-2013 SP1. Nope, not even 2013 RTM. Nothing going to work. So if you try to access like a mailbox hosted on 2010, 7, just not going to show up. So just keep in mind, this is an option in like greenfield-ish environments right now. Because are there any greenfield 2013 guys in here? Yeah, a bunch of them. Well, not that bad, really. OK. So those guys could actually do that. They could pull it off, which is quite nice. OK. We can either go to ADFS or, again, to the web proxy to claim our claim to fame, which is kind of cool. And we can finally, again, do pre-authentication on web without being domain joined. Says hold for applause there. Does it? Oh, come on. Let's get hyped. All right, man. Implementation overview. So a bunch of things that you need to keep in mind for that. Requires manual creating of a relying party trust. So when you create a relying party trust in ADFS, you usually just have like a service URL to go to. You just point it to a service URL, and it just sucks down all the information there is and just configures a automatic relying party trust. Yep, we don't have that. We never went ahead and did that, so it's kind of like a bunch of manual steps there. We need to get a bunch of claims in there. So there's going to be like a user principal name claim. We need a primary SID claim, and we need a group SID claim. So the funny thing is, though, I tested with only the UPN claim, and it went just fine. But documentation is very clear on that. We need all three claims. There's probably some corner case scenario that I didn't get around to test. There is some configuration needed on Exchange as well. So we need to set an ADFS issuer, which is basically going to be your ADFS server, like https.sts. whatever, blah. There's going to be ADFS audience URIs, which is only really URIs on which you would expect Exchange to listen on. So if someone goes ahead and says mail.blah.com WAC OWA, and it's not in the ADFS audience URIs, Exchange is just going to say wrong audience URI, thank you, come back later. Okay? So just make sure that all the URIs you'll be using for ADFS out to Exchange are in there. And we need the signing certificate thumbprint in there. So that kind of gives Exchange the chance to verify that the token that we get is actually signed by the certification authority we love. There are steps out there that have been out there like for 2 or 3 weeks now, and I've been a part of writing these steps. So yep, have a look at them. They are pretty detailed. They tell you how to build those claims. They tell you how to configure those relying party trusts, and it's working just fine. All right, bringing HA to WAP. It's easy. Well, it's easy. Nothing's easy in life, is it? So bring up new web application proxies. Yeah, okay. We already talked about that. We're just going to share the same configuration, right? So we're just going to suck out the configuration of the ADFS box in the backend and be done with it. Well, that's cool from an implementation perspective, but that's not cool from a user accessing perspective, is it? So you want to get HA, you need to think about some form of load balancing. Can be third party, again, can be Windows load balancing. We would fully support that. You can do whatever you want with that. We don't need any session affinity with that. So the cookie that we hand around, the edge access cookie, right, the one that I've been talking before, the edge access cookie can be decrypted by all of these because they have like the same private key coming from ADFS. So whichever web application proxy we had, you'll still be authenticated. You don't need to re-sign on. You'll still get your application that you publish, so it should all be good. All right, I'll quickly take you through the steps required. So we need a relying party trust. So these steps are still for 2013 pre-SP1. For the SP1 steps, pretty simple, go to the document. They are not that much off, really. All right, so we would want a relying party trust. So relying party trust, again, is like credentials flowing out of ADFS. So the Active Directory guys are probably going to kill me for that description, but that's kind of how I figured that one out. Kind of like credentials going out of ADFS, of ADFS, with the claims provider trust being like credentials going into ADFS. All right, so we need a identifier there. So it says non-claims aware. Non-claims aware pre-SP1. Okay, so that's what we did pre-SP1. We had a non-claims aware relying party trust, just meaning whenever something's going in there, you'll need to do KCD. Okay, that's kind of what it's supposed to be saying. Instead, it's called non-claims aware relying party trust. Okay. So just keep that in mind if you're ever going to play with that. So it's going to ask you for an identifier. So in my case, it's mail.sur8.at. It's just saying, OK, whenever something's coming in for that URL, just go to that relying party trust and do the credential steps from right there. I can do user filtering, saying, OK, a couple of user groups are allowed to do that. A couple of user groups are not allowed to do that. So we can all do that. We can have MFA that we can have multi-factor auth in there. So if you like hook up RSA tokens or whatever you want to into your ADFS, you're more than welcome to use that here. It's all good. All right. And I'm just going to permit all users for the demo there as well. So what I'm having now is nothing else than a relying party trust, meaning if something comes in for mail.blah, just do a KCD to the backend, whatever it might be. All right. So for KCD, you always need delegations, right? KCD will not work without a delegation. So you need to put in AD delegations there as well. Pretty easy. If you have like a single server, that's going to be pretty easy to do. Just put in a delegation to the single server. If you want to have a delegation like to an array of CAS servers, you would obviously need to put in a delegation for like a shared name. And we can just use the ASA name for that. And that's what we're doing here. So we put in like a web delegation to the alternate service account that we have for Kerberos in Exchange in most deployments anyway, and have web delegate to that one, and have web understand that one. Yep, so with that, there's actually a bunch of nice things there. So if web and Exchange are not in the same domain, and keep in mind this is 2013 pre-SP1 still, and we needed to be domain joined for KCD to work. If they were not in the same domain pre-Windows 2012, that was usually like a bummer. You just say, nope, doesn't happen, no way. 2012 kind of like changed that a bit. So you can now do Kerberos constraint delegations across domains, across forests, whatever you feel like. So With that in place and a bunch of prerequisites, so there's a bunch of hard recs that are in the link that I posted there. You can put the web server basically anywhere you want, in a different domain, in a different forest, and we should still be able to pull off delegation really easy. The only thing that's kind of changing, though, is the way on how we set delegation. So delegation is now only being set on PowerShell, which is, I guess, fair. You're not going to do that often, but it's possible, which is good. All right, configuring WAP, installing WAP. I'm not going to talk you through that, really. The only thing that I kind of wanted to point out is asking for an ADFS proxy cert. So this is kind of like the same cert that you would have on the back end. And that's it. It's just install web application proxy. Nothing fancy, nothing stupid there. All right, pre-auth for OWACP. So in that stage, we would be asking for a backend server SPN, a backend server URL. So the thing to keep in mind here, that this is, again, 2013 pre-SP1. With the backend server SPN, very important. What do you guess is the most common mistake people made, that they put in http:// mail.blah in there, right? They don't put http whack name in there, they put http:// in there, which is kind of like the most common mistake people make out there. And with that, you're more or like mostly done, 99% there. So you have now deployed ADFS, you have a web role deployed, you have a web application deployed, which is going to use KCD to the backend. You have a delegation in place. So yeah, all good. Pass-through, I'm going to spare you pass-through, really. There's one thing more to do. So we don't do very well without disable translate header URI in request headers thing. So what this basically does, it disables the rewriting of HTTP host headers in web that came down from the web guys directly. They asked me to include that there. OK. With that being done, all your stuff should work for like 99% of everything. All right, there's still more to come. In the web world, we do not longer have IIS, right? So all the HTML that's being served up is not from IIS. We're directly hooking into http.sys and just pulling stuff in from there. The problem is with the way that http.sys selects a certificate, it expects an SNI indicator. Okay, so the problem is that older clients, XP anybody? Windows XP still? One guy, come on. So XP still, older ActiveSync devices, they don't send an SNI indicator. So you need to assign a default SSL certificate for that. So if you fire up an XP to something published by web, you'll get that. Cannot do it. You can ping it just fine. You can telnet on 443 just fine, but it's going to show up like that. So we need to assign a default certificate to clients not sending an SNI header. And the way we do it is in NetSH. We'll just pick up like the thumbprint of the default cert we want to have and assign it to http.sys. And after we've done that, XP is one happy pappy. And all their ActiveSync devices will be pretty happy with that as well. All right. Now, one for the books. It's like one of the coolest stuff you're probably going to see at that Mac. What about cross-forest authentication? You have your forest forestfabricam.com. There's Exchange there. There's ADFS there. So if somebody would be logging on with a Fabricam user, just perfectly fine. So how about Contosa.com? Contosa.com is like our partner, or we are hostess for Contosa.com or whatever. So they would be needing to have like a Fabricam user as well, right, to slam into our ADFS portal. Well, not really. So what we have been dreaming up here is a scenario where we do UPN rewrites. So they would still obviously enter mail.fabricam.com, be redirected to sts.fabricam.com, and be done with it. Nice, all cool, all fancy, it's just working fine. But at that stage, we can have them bouncing off to a different ADFS instance. So they can actually enter their own credentials, like credentials from Contoso.com to access their mailbox on fabricam.com without any Windows Trust, without any associated external account, nothing. It's working just fine. There's a bunch of caveats being around with UPN rewrites. We all know that, like with people like dream up multiple objects that have the same name, you would need to take care of that. But otherwise, this is working just fine. It's working fine for 2013. It's working fine for 2010 as well. All right? That's pretty cool. It's actually what I want to demo about that. So we're doing magic by UPN rewriting. So we get a UPN claim that says user at contosa.com. We rip out the last part of the claim, replace it with a different part, done. That's it. Okay? And we slam the claim down to OWA and say, OWA, please accept that, thank you. And OWA will. It's going to be just fine with it because you're the authenticated issuer for that. It's just going to say, yeah, cool, I can do it. And it works in KCD and ADFS authentication scenarios, just fine. All right, 2010, 2007. Yeah, all good. 2010, you can do the same stuff like I demoed, like I've shown you, like for the last half an hour. 2007 is a bit of a difference because we didn't have an alternate service account name in 2007, did we? Nope. The ASA account appeared in 2010. So if you want to do pre-auth to 2007 still, you would need to publish a single server or do some unsupported magic on the OWA virtual directories, which I'm not going to talk about. All right. Cool. A WAP deployment. So I would encourage you to go ahead and play with it. So like with a lab deployment, it's always the same stuff. You use it, and then you just have it sitting there like for a bunch of days, and it's not going to do anything, right? So the bad thing is, after WAP is being turned off for 15 consecutive days, it's just going to stop working. Nice. You fire it up, you go to a demo like I'm going here, it just stops. Thank you. That's good. The thing is, that's actually a bug pending for this, and they will probably fix it in the next release, that the certificate that we use to authenticate to ADFS is only valid for 15 days. And if we are not online for like 15 days, we're just not going to create a new one. We could easily create a new one, but we don't. So the workaround for your lab deployments is to go to the registry, just set the proxy configuration status to 1, run through the configuration steps of WAP again. It's like only going to click, 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 done. And you should have a working WAP environment again. We also have a WAP external logout in place. So it's kind of like the same stuff that TMG SP2 brought. It's like a soft logout, right? So you have like a logout policy. Who is the logout policies? AD logout policies? Yeah, you love that. If your logout policy says like after 10 attempts, we'll lock your account, you would configure the soft logout to be like 5 attempts, 7 attempts, whatever. And what we would be doing really is you can log out to ADFS just fine. And if after like 5 attempts, just no good auth coming through, we'll just lock your account for a bunch of minutes, really. So we have something called the extranet observation window, which is very self-describing, isn't it? So the extranet observation window is really the time that we lock a user out. We have the extranet lockout threshold, where we just say, OK, for how many further attempts do we lock the guy out? All right. So demo. This is an unstaged demo, so please hang with me on that. I hope it's doing something. Hey, plus and VGA. All right. Very cool. So what I got here for you is kind of like a small snippet of my lab, really. And this is like what WAP looks like. Okay? Pretty simple, pretty straightforward. You can actually create stuff in here, like publish new applications, but you can modify stuff, which is kind of weird. So once you publish your application and you want to change it afterwards, it's partial only. But hopefully that's going to change as well. All right, so you already see that I have like an ECP application here. So I'm just going to walk you through the steps of creating OWA applications for that. So it's going to ask me what do you want to do, and obviously I want ADFS off, right? Pass through, come on, everybody can do that. So let's do the proper one. Let's do OWA. So it's going to ask me for my relying party trust. So I created a relying party trust that's issuing claims to OWA. So it's going to ask me for a name, OWA. Oh, come on. And I want to give it a name. And the name in my lab, sorry for the crappy naming again. It's going to be that. And it's going to ask me for an external certificate. And as you can see, those are all my ADFS proxy trust certificates, right? So after 15 days, I get a new one, new one, new one, new one. So that lab has been around for quite a while. All right, so I'm going to use that certificate there, and I'll hit publish. All right, very cool, very fancy. And if I have a look at my client now, God willing, yeah, that's the thing with unstaged demos. All right. We should be seeing the ADFS login portal, right? So that's pretty easy, pretty straightforward. Logging in with my domain credentials, test E2K13 is a domain user in the same domain. Mistyped my password, thank you for that. All right, we should be seeing OWA coming up really soon. So I just booted up that machine, hang with me while it's loading. we should get something back. So it bounces us off to ADFS server 1 AT, and any minute now it should give us the Outlook Web Access donut saying almost there, which is probably the best thing we ever had. Opening your mailbox. Oh, come on. Still working on it. Almost there. All right, there. Woohoo! Lovely. Thank you for that. All right, so with that being demoed, let me show you the better demo. Let me show you the cross-forest demo. Who wants to see that? Yeehaw! There you go. Bunch of hands in the air. Love that. All right, so we need to go. And so this is kind of what relying party trust looks like. So this is our OWA relying party trust, which is basically just saying, yeah, issue a claim to OWA. It's not doing anything more than that. Look at that. It's just saying, yeah, issue a claim. That's it. We're just issuing a UPN claim. Nothing more than that. So we will want a claims provider trust too. So claims provider trust is authentication flowing into ADFS. So I'm going to add a second forest. And the second forest here is called SIR2. I'll just pull it up. So this is like my automatic configuration, ADFS SIR2 AT. Let's see if we can actually dream that up for me. Thinking. Yay. Pretty lovely. And we will do a claims rule there. And we obviously we said we kind of need to do some magic with the UPN claim, right? We need to rewrite it. We need to rip out the last part of the UPN, like where it says Contoso or whatever. In my case, it's going to be SIR2.local. We need to rip that out and replace it with something different. So that's what I'm going to do. I'm going to do transform an incoming claim. The specified claim that's going to come in is a UPN claim, and I want a UPN claim to be flowing out of that. And just be very generous and say, yeah, replace everything with SIR1.local. Yeah, good. Love that. All right. Back to the client. Let's just flush the IIS cache, the Internet Explorer cache right there. Now let's see what's happening. All right, so it's going to ask me now, dude, are you from SIR1? Are you from SIR2? I'm from SIR2, come on. How can you not know that? It's going to bounce me over to SIR2. Have a look at the URL. It says adfs.sir2.at. Nice. So I'm going to provide, obviously, my SIR2 credentials. All right, so there's going to be a bit of ADFS bouncing around going on now, which is like, for whatever reason, taking like 30 seconds in my lab. I don't know why that is really. We've tried to figure that one out yesterday, but we didn't get to the bottom of it. So with that in place, we should create a UPN claim for test E2K13 at SIR2.local. And we should give that claim to ADFS1. And ADFS1 should say, hey, there's a claim I need to transform, rip out the end of it, and put in SIR1.local. And hopefully, God willing, demo God willing, it should log us on. We'll see. Should we crack any pirate jokes while we wait? No? No pirate jokes? Does anyone have a good pirate joke? No. OK. So we've been bounced off again to ADFS SIR1, which is a good sign. Thinking. Still thinking. God, I would hate if this fails. Be super annoyed. Huh? Question while we wait? No, it's working. Look at that. Way! Woohoo! Oh, that's something usable, isn't it? That's something that probably people can go out there and use. Can we just have questions like that guy's just first, really? Okay.
So is anyone in the real world using this yet? Or is this all
So I have personally, so I can only talk about my personal experiences. Yet people are using web. People are using web, really. I don't think that a big one has actually implemented UPN rewrites. Okay? Yeah? Yeah, you do that? Okay. It's doing its job? Okay. Yeah, it's working. It's doing its job. There you go. Yes. Yes, I did.
with exactly the same name as the
Yeah.
account in the first forest?
Yeah.
Am I missing something? I mean, isn't that like
Yes, that's what I said before. There's like the thing that we just in the demo very granularly replace everything, right? We say whatever's coming in, we just rip it out and do something with it, right? Obviously, and there's probably one guy in the front with us you should be talking to. There's ways to overcome that, like do some more clever filtering on that. A good question, and we've heard that one a bunch of times. All right.
There's one.
So let me just close the session down. Really, you saw the demo. I hope you liked it. It's good fun. It worked. Thank you, Demo God. With 20 seconds to spare, I'm going to say thank you. I'm going to take questions right up here if you want to. We'll be down there in the expo hall after that, I guess. They asked us to go down to the expo hall. Please do fill out your evals. We'd like to know how we did, how many private jokes we didn't do that we should have been doing. Have a great Mac. See you soon. Thank you. It doesn't.
Hey, no problem. Thank you. Thank you.
So, you said you were going to be posting a new blog
That's
on,
right. On the third option.
on the third option.
Yep.
Okay, all right,
Yep.
well, that sounds good. So really, though, you need like a load balancer or something in front of your ARR servers?
No, you don't. So what you can do is, let's say, for high availability, you put two IaaS ARR servers.
Yeah.
It's sitting in the DMZ. You just Windows network load balance them. That's it.
Okay.
That's it. So when the traffic comes up from the outside, hits your firewall, uses Windows network load balancing, sends it to either of the IaaS ARR servers. Then the IaaS ARR, because of its
Has the web farm capability
correct,
going back to
and
the
then it
same
distributes
system,
it.
right,
So you
right.
can have 5, 6, 10 CAS servers, whatever. It'll just spray it across.
And what are your recommendations on sizing them?
Oh, so
'Cause I looked out there,
yeah.
I couldn't
So
find anything
look,
really on.
yeah. So look for it was blog part 4 of my blog on the Exchange team site.
Okay.
So just put part 4. Open your favorite search engine, put part 4 and put IaaS ARR. So at the very bottom so there is no true sizing because we still don't know how many customers are using it. So we still haven't done full blown, for Exchange, we've done full sizing. We haven't done it, but there is a baseline that I have mentioned there. So at the very bottom, because it's just doing basic URL filtering and it's just doing, load balancing.
Right.
So
I can imagine it being too much. But then
correct.
again, I
Yes.
don't know.
So there is a
Some of
baseline.
the bigger clients
Correct.
have more-
So there at the very bottom, there's a small table. So just use that as a baseline to start off with. And it's very, very simple. I think for 2 quad core with 4 gigs of RAM, you can scale it up to, I think, 2,000 or 3,000 for one box. And then you slowly keep adding the more you add. And if you can have more IaaS ARR servers, you can make them behave as active-passive or active-active. So let's say if you put 4 ARR servers, all of 4 of them can just take all the traffic from the outside, and then they can do load balancing again. So it is pretty flexible that way.
Okay.
So
No,
it's a choice.
That sounds good. And then one last thing.
Yeah, no
and then
problem.
I'll let you go. In your example where you moved the other ARR servers.
Oh, okay, yeah,
inside,
yeah.
inside
Correct.
the network.
Correct.
And and really, what are you gaining from doing that? I mean, couldn't you just point everyone on the internal to use the CAS servers?
Oh, yes, you can. So that's
Just
so,
directly versus coming in.
yeah. So internally, how would you do it? Internally, probably you would create multiple DNS entries because you have CAS. There is no an RPC form. It's a CAS now is all individual. So you would probably have to create multiple DNS entries. So for mail, let's say you've got 2 CAS servers. You will see mail.contoso.com, IP number 1. Again, mail.contoso.com, IP number 2. So that then it's using DNS round robin. So the internal users are just using DNS round robin. So first time it goes there, then it goes there, then it goes. But it's not load balancing. It's just distributed.
Right. Yes. Yeah.
Correct.
Okay.
So it's just an option. So you just put it there, then it's load balancing. So in the event CAS1 truly goes down, DNS round robin doesn't know. It's just going to blindly send 1, 2, 1, 2, 1, 2. Where if you have the ARR, if it sends it, ARR says it.
But I mean, if you point internal to the load balancer
right.
in front of your CAS servers, wouldn't that just do the same thing?
Yeah.
Okay.
Yeah.
Okay, all right.
If you
No, most of
no,
them.
yeah, if you,
Yeah,
yeah, most of them because from 2000 days, because Microsoft said you have to have load balancers.
Right.
So yes,
Well,
you
yeah,
have
that
it.
maybe
If
load
you don't,
balancers
it's just as I said, it's food for thought. So just
I
think
got
about
you.
it. If you
Okay.
like it, use
Okay,
it.
that kind of threw me for
Yeah,
I was
yeah,
like,
no,
oh, now we
no,
need
no,
an
no.
internal too. Okay, cool. Thank you.